Okay, so this video is the third in solving logarithmic equations, and this one will involve condensing. So you learned how to condense earlier in this chapter, and the reason is very specific. It's so that you can do problems like you're going to see today. So here are the tips for today. You've seen a lot of these already. Again, I will let you read them for yourself. And just kind of really pay attention on these examples. There are some cases where you will condense and then you'll end up with 2 logs. And then there's going to be other cases where you condense and then you'll have to take it out of log form completely. So hopefully I'll be able to keep those clear in your head. Okay, so take a look at this example. There are 3 logs in this problem, right? That's a lot of logs for any problem. There's 1, there's 2, there's 3. Now, the good news is they're all base 3. That does not, and let me repeat this does not mean that you can just get rid of the logs, okay? You cannot get rid of them. What you can do over here on the left is you can condense, all right? Because these 2 logs are held together with addition, I can condense this and multiply the 2 arguments together, all right? In other words, I'm going to multiply this 4x plus 6 with this 4. I can multiply those together and get 4x squared plus 24. Now that's going to equal this side. I can't get rid of it yet. Okay, now, all right, and notice how it's changed now. Now I don't have 3 logs in this problem anymore. I only have 2. So because I have the same base on these 2 logs with an equal sign in between, I can now set these 2 arguments equal to each other. That's a plus. Equals 28. Okay, so subtracting 24, I get 4x squared equals 4. Dividing both sides by 4, I get x squared equals 1. Taking the square root, I get x equals plus or minus 1. Now, arguments after logs cannot be negative, okay? That doesn't mean that I have to discard one of these answers. It means I have to check, if I plug it in here, do I get something negative in the parentheses, which I don't. So that means both of those answers are totally fine. Okay, scooting this up. Okay, so this one has 2 logs. You can see them right here together on the same side. So I'm going to condense that side. Now notice they're held together with subtraction. So when I condense, I'll have x plus 1 divided by x. Okay, now on this one, right, I don't have a log on each side. I have a single log. When you have a single log, the only thing you can possibly do is get it out of log form completely. So I'm going to have 4 to the third is equal to x plus 1 over x. 4 to the third actually equals 64. So let me just change that to a 64. I'm going to cross multiply to solve this, giving me 64x equal to x plus 1. Excuse me. All right, moving this x to the other side, I get 63x equals 1. And then dividing by 63, you get 1 over 63. All right, so again, if you have to, go back, look at the 2 examples again. Okay, so this one is going to be a lot like the first one. Okay, it means I need to condense the left, right? I'm trying to get 3 logs in this problem to only be 2. So condensing, you'll end up with x over x plus 4 equals log base 3 of 22. And now that I have a log on each side that has the same base, I can set the arguments equal to each other. I'm going to put the 22 over 1 so that I can cross multiply. Here, I'm going to get x, and here, when I distribute, I will get 22x plus 88. Then I will subtract 22x from both sides. I'll have negative 21x equals 88. All right, and then lastly, I will divide by the negative 21, and I get negative 88 over 21. All right, seems to be fine. Moving on up. All right, so this is a lot like example 2, where I need to condense the 2 logs down to a single log. So, oh, notice there's no base here. Okay, this is a good example. The reason this is a good example is the first time you're actually seeing common logs, right? I talked about it in the last video a little bit, but I didn't really explain. All right, so I have condensed. When you don't see a base right here after a log, it's understood to be a 10. So you can just write that in as a 10 right now. And now I'm going to take this entire equation out of log form and put it into exponential form. And if I put a 1 under this 10, I can cross multiply and solve this thing. I'll get x minus 9 equals 60. And when you add 9, you get every mathematician's least favorite number because students giggle. And then example 5. Let's see what this one looks like. All right, so I'm trying to solve for k. Here's my k. So I'm going to move this -4 to the other side. So I'm going to have 18k equals 75. All right, I don't know how to solve this without using logs, right? I'm kind of stuck. I can't change 75 to be the same base as this. So I'm going to write it in log form. So log base answer equals exponent, right? And this is something that I can put in my calculator and get a decimal answer of 1.4937. All right, again, this is going to be similar. Okay, so on this one, to try to get this alone, right, I'm trying to get this alone, I'm going to divide by the 4. So I'm going to have 11 to the m plus 7 equals 6/4. If you want to reduce that, that's fine. I'm going to be putting this in my calculator anyway, so it'll get all handled in the end. All right, I'm going to take this out of exponential form and put it into log form. So log base answer equals exponent. All right, next I'm going to subtract 7 from both sides. So I'm going to have log base 11 6/4 minus 7. This is calculator ready form, but if you do put it in the calculator, which I'm hoping you will do, you should get negative 6.8309. And that's my last example. Thank you for your attention.